Now on to isosceles triangles. Isosceles triangles, again, the definition is it's a triangle that has two sides that are equal. And so right here I have an isosceles triangle. Now if I label this isosceles triangle A, B, C, if they tell you without a picture that something is an isosceles triangle, they say that triangle DEF is an isosceles triangle, they will either tell you which two sides are equal, so DE, EF, something like that. In this case, AB and BC are equal. Or if they write triangle ABC is isosceles, and they don't give you a picture, they don't tell you which ones are equal, because again, it's not all of them, it's just two of them. And they don't, or anything like that. What you have to assume is that B is the vertex where the middle one here, so this one's B, is the vertex where the isosceles triangle comes out of. So in this case, B, the two equal sides come out of B. The ones that come out of, that's the vertex. That's the one we're going to write in the middle when we write an isosceles triangle in the book. So if you see that, I just want you to understand that sometimes they'll say that without actually telling you which sides are equal. So just assume that the middle one, the ones coming out of that, those are the ones that are equal. Okay, so that's just a side note. Here we go on to the lesson. So here's an isosceles triangle. Two sides are congruent. Now I can prove something that's true about this if I draw an angle bisector. Remember, an angle bisector bisects the angle. So I'm going to bisect the vertex here, B, where the two equal sides come out of. That means, by definition, that that angle is congruent with that angle. Okay? Now I want you to see side angle. I already have side angle, side angle, side angle. In order to prove it, I need a third piece. So I either need another angle or need another side. And in this case, you can see from these two halves of the triangle, I cut the triangle in half. This green line that I drew is the third side of the triangle, and it's congruent to the other triangle here. I want you to see this is now two triangles. I already know that these two angles sides are congruent. That's the definition. I drew an angle bisector. So by definition, those angles are congruent. And because this line, those are the same line here, it's congruent as well. So I want you to see that what I've done is I've drawn two congruent triangles. This triangle is congruent to that triangle, which means that every part in those triangles is congruent. Every part is congruent. Corresponding parts of congruent triangles are congruent. CPCTC. CPCTC. This is something that we'll be using over and over and over again. So if that is true, that would mean that angle A here corresponds to angle C over here in these two triangles. So angle A must be congruent to angle C. Okay? So we'll see what this just means in general for an isosceles triangle is if the two sides are congruent, it's isosceles, then the two angles beneath them also are congruent every single time. Okay, so let me refresh that with a little clearer picture. If it's isosceles, then the angles at the base underneath the two sides that are congruent are also congruent. That's always true for an isosceles triangle. But the reverse is also true. If you know a triangle has two congruent angles, then you know it also has two congruent sides. So either way, two congruent sides means that it has two congruent angles. Two congruent angles will mean that the triangle has two congruent sides. We can extend this further for an equilateral triangle. Equa meaning the same or equal. Lateral means side, so all sides are equal. So all three sides are equal. We can extend this because if these two are equal, we know that these two angles must be equal. But also, if these two are equal, then that angle and that angle, by the same reasoning, would also be equal. And then likewise, if I looked at these two, then those two would be equal. So an equilateral triangle is also an equal angular triangle. All the angles are equal. And vice versa. If it's an equal angular triangle, it's an equilateral triangle. Now, we've seen that kind of before, but this is an extra step beyond isosceles. So isosceles and equal angular triangles and equilateral triangles have some things in common. So let's move on to solve a problem like this. In this problem, they have told me in the language, I'm not going to write it down because it's really long. In the language, they've told me, first of all, triangle CDE is equilateral. So that means all these sides are congruent. Okay? And they've also told me that triangle FAE is isosceles, meaning that these two sides are congruent. And they've also told me that triangle ABE is isosceles, meaning that these two sides are congruent. Now I've got like 1,000 triangles, and then they tell me something like this. They'll tell me that this angle right here is 40 degrees. And now I have to find all the rest of the angles.